Welcome to the Walton Pi. Today we're going to be talking about inverse functions. So an inverse function of a function f is a function f to the minus 1 that we read f inverse that satisfies the following requirement. F inverse of f of x is equal to x for all x in the domain of f. So this actually gives us some pretty strict restrictions on when a function has an inverse. So since we need f inverse of f of x to be equal to x for every x in the domain of f, that tells us that f of x cannot give the same output twice in order for there to be an inverse. So why can't it give the same output twice and still be an inverse function? Well, let's imagine that it did give the same output twice. So let's say that f of a and f of b both gave the same output. So f of a equals f of b equals c. Since inverse functions satisfy f inverse of f of x is equal to x for all x's, then we know that f inverse of c, well, c is just f of a, so that's f inverse of f of a, that must be equal to a. But we also have that f inverse of c is equal to f inverse of f of b, so f inverse of c must also be equal to b. So f inverse of c gives both a and b as outputs. So if a is not equal to b, f inverse is not a function. So the inverse function can only exist when f is what's called one-to-one. So a way to see if a function is one-to-one, it's also referred to as injective in other classes, is to use what's called the horizontal line test. So let's look at these two functions. Both of these are valid graphs of a function, but one of them is not one-to-one. If we draw this horizontal line, we see that the first function, no matter where we put that horizontal line, it's only going to intersect the graph one time. That tells us that it is one-to-one. One output only has one input. The second function, though, is not one-to-one, because one output can have more than one input. So the first one is one-to-one, but the second is not one-to-one. Therefore, we can say that the first one will have an inverse, but the second one will not. I hope this was helpful in understanding the concept of inverse functions. I'll be going through some examples in a future video, so please subscribe and like this video so that you can be able to see that when it comes out. Have a great day and good luck with the rest of your math.